Video lecture for session 1.1. This is for college algebra. My name is Jorge Gavian. So for this particular section, we're going to be talking about solving linear equations, solve equations that lead to linear equations. Then we're going to go ahead and solve a problem that can be modeled by linear equation. So again, one of the things that we've done thus far in the review is replace original equation by a succession of equivalent equations until we get one that has the obvious solution. And so these are the steps. I'm not going to go through all of these. You guys can read them, but we've done all of these thus far in the review. And so here's the first example. We have 3x minus 5 is equal to 4. So of course, what we're going to do is add 5 to both sides. That gives us 3x minus 9. And then divide both sides by 3, and we get x is equal to 3. So then we check to make sure that it works. And it does. So the solution is, in fact, x is equal to 3. Always check your work. You're going to save some time and also might save you some points. And so these are the steps for solving equations. Of course, we always want to list any restrictions of the domain. We talked about that today in class. We're going to simplify the equation. And the result in step 2 is a product of factors that equal 0. We can use the zero product property. And then, of course, always check your solution. So solve a linear equation. Again, let's define what a linear equation is. A linear equation in one variable is an equation equivalent in form to ax plus b is equal to 0, where a and b are real numbers and a does not equal 0. So here we have the first equation. So we have 1/2 times x plus 5 minus 4 is equal to 1/3 times 2x minus 1. So what we did here in the second step is multiply both sides by 6. And when you do that, you have to distribute the 6 to the first term and the second term, which is what they did in this line here. And then, of course, 6 times 1/3 is simply 2. And so here we have the line here. We do distributive property. We're going to go ahead and combine like terms. What they did here was add 9. You can do anything that you want as long as you do something, right? We could have subtracted 3x, subtracted 4x, added the 2. They just happen to add the 9 to both sides. And then so we had 3x is equal to 4x plus 7. Subtract the 4x from both sides. We're going to end up with negative x is equal to 7. We cannot have that. And so we multiply both sides by -1, and we get x is equal to -7. And then we check it, and in fact, it works out. So the next one is solve equations that lead to linear equations. So here you can see that we have 2y plus 1 times y minus 1 on the left, and then y plus 7 times 2y minus 5 on the right. So we're going to go ahead and FOIL both sides. And when you FOIL both sides, you end up with this right here, which is the second line. And so at this point in time, what they did here is subtract 2y squared from both sides to get rid of the 2y squared term. And then in this line, they added 1 to both sides. And then they subtracted the 5y. And then, of course, divided by -6. And then they checked it, and the solution is, in fact, 4. And all of these steps we've done, you can go ahead and confirm them. They did skip some of the steps here. They didn't actually write them out, but you guys can confirm that. So here's an equation with no solution. So we did one similar like this in class. So of course, it did have a solution. So the first thing that we're going to do is note that the domain is restricted. X cannot be equal to -1. And so we're going to multiply both sides by x minus 1. Again, here we're going to distribute the x minus 1. So the fraction gets the x minus 1, and so does the 2. On the right side, the denominator and the factor that we just multiplied by actually cancel each other out. So we left with 3. We're going to go ahead and combine all of these like terms. So we end up with 3x plus 2x minus 2 is equal to 3. And then 5x minus 2 is equal to 3. We're going to add the 2 to both sides and then divide by 1. Now, what happens here is that we know that the restriction is that x cannot be equal to 1. So therefore, there is no solution. The solution set is the empty set. So we're going to solve problems that can be modeled by linear equations. So I'm not going to read all these steps to you, but these are the steps that you can follow when you solve an applied problem. So the one that we have here is a total of $18,000 is invested, some in stocks and some in bonds. So if the amount invested in bonds is half that invested in stocks, how much is invested in each category? And so the first thing is we're being asked to find the amount of the two investments. These two must equal 18,000. So then what we're going to do is we're going to let x be the amount that's invested in stocks. And then 18,000 minus x is what's invested in bonds. And we can do that. We could have easily said, okay, x is in bonds and 18,000 minus x is in stocks. And so we're going to set up this table. And so x is the amount in stocks. The amount in bonds is 18,000 minus x. The reason is because there's 18,000. And then we also were told at the beginning that it's 1/2 whatever we invest in stocks. So 18,000 minus x is equal to 1/2 x. And then we're going to go ahead and solve this. So we add x to both sides. Now there's a 1. The coefficient of this x is a 1, so it's 2 over 2 plus 1 over 2, which is 3 over 2. And I talked about this in class. Multiply both sides by the reciprocal when the coefficient is a fraction. And so that cancels out. So then x is equal to 12,000. So that means that 12,000 was invested in stocks. And then the difference of that, the 6,000 was invested in bonds. And that's the end of section 1.1. Thank you.